Greetings and welcome. Subscribe the channel Thermal Engineering for video sessions. In this session, you will be able to explain properties of fluid as vapor pressure and its importance. Vapor pressure. This term is analogous to the saturation pressure term, which is normally used in thermodynamics subject. Saturation pressure is a pressure corresponding at which liquid starts boiling. This pressure is a pressure exerted by vapor on the liquid surface. So for the better understanding, first of all we will understand the difference between evaporation and boiling term. So here both are shown. The left side is of evaporation and right side diagram is of boiling. In case of evaporation is taking place at liquid vapor interface. So here we see this is a pan or vessel which is placed here, which is filled with liquid. So here is no application of heat below this pan. Now in this case, naturally molecules escape from the liquid surface. So here below this surface interface we find here liquid only, and above this interface we find air plus vapor molecules. It is a slow process, hence we cannot visualize evaporation process in most of the cases. In open atmosphere, without changing temperature, water from lake or river evaporates. So this is called as evaporation. In the nature also we find that clouds form naturally. When these clouds are getting cooled, rain falling takes place naturally because of evaporation. Now the second concept, that is boiling. Here we see boiling is taking place at solid liquid interface. Means here we see this is a vessel which is kept on this interface. Here is the application of heat. So by the application of heat here across this solid interface, when the heat is transferred, then here vapor molecules are forming. So here this is the liquid vapor interface and this is the solid liquid interface. So across solid liquid interface heat is transferred, these molecules are forming, then these molecules are escaping across this interface, that is liquid vapor interface. Due to boiling, pressure increases. In this case, here we see bubble formation take place due to vapor pressure overcome the atmospheric pressure. Means we say that vapor pressure is above atmospheric pressure, then here bubble formation take place. Now this is what taking place in case of boiling. All liquids have tendency to evaporate or vaporize from liquid to gaseous state. So here we see vaporization take place due to continuous escaping of the molecules from the free liquid surface. So here this is the magnified image where we see this escaping of molecules from the free liquid surface. That is what vaporization. Now when the liquid is confined in a closed vessel, here closed vessel is shown, the ejected vapor molecules gets accumulated in the space between the free liquid surface and the top of the vessel. This vapor exerts a partial pressure on the liquid surface. which is known as vapor pressure. Now, as molecular activity increases, the vapor pressure increases along with temperature and pressure. So here we see this temperature and pressure both are increasing when the vapor pressure increases. So it can be cleared by this graph. In this graph, on the horizontal axis temperature is shown and on the vertical axis pressure is shown. So as the vapor pressure increases, temperature increases, or vice versa. Now this temperature is a saturation temperature. Now here in this image we see these are the two closed vessels which are at different temperature. At the left side the low temperature and right side is a high temperature. So here we find that here these are the molecules which are escaping from the liquid interface. This number is low because it is at low pressure, low temperature, and here right side, here this number of molecules which are escaping from the liquid interface, that is high because here is a temperature higher than the first case. So in this case we say that higher the vapor pressure, because here we see that more number of molecules, means here the vapor pressure which is acting on this liquid interface will be high. So higher the vapor pressure, more volatile is the liquid. So in the real life we see these two substances, petrol and water. So we know that petrol is more volatile than the water. Now this is because of more vapor pressure of petrol than the water. Here mercury we see, which has very low vapor pressure and high density. That's why it is deposited at the bottom of this tube. Generally manometer fluid is exposed to the atmosphere, so low vapor pressure is recommended there. So that is why mercury is used in manometer. The reason is, if we use water in the manometer, after some months, say 2 to 3, water gets evaporated slowly. So mercury is used in manometer. Also, second reason is mercury is low volatile than all fluids. Importance of vapor pressure can be understood by the phenomenon called as cavitation. So cavitation is taking place due to low vapor pressure in impeller section of centrifugal pump. It occurs when the static pressure of the water in pump casing falls below its vapor pressure. As pressure there is below vapor pressure, bubbles, means vapor bubbles, are formed there. When these vapor bubbles enter in high pressure zone, they get suddenly collapse and gives rise to high impact pressure there. This pressure developed by collapsing bubbles is so high that the material from the adjoining boundaries gets eroded. So here we find this is erosion of the surface which is taking place at the impeller blade. So by this, cavities are formed on the boundary surface. Now here from this clip we can understand how to recognize whether the cavitation is taking place in the pump. So here we see here the inside pump, the vapor which is formed, that is shown by this pink color, that is called as flash steam also. So when the cavitation is formed, then their pump oscillates due to cavitation. So it is indication of cavitation. It leads to failure of pump impeller. So here we see on this surface erosion and pitting action. It causes additional noise and vibrations while the pump is working. This happens with the fluid with high vapor pressure, means for example petrol. So from this we can understand that when we are going to design a pump as per the type of fluid, it may be water or petrol, then we have to take care that inside the pump the pressure at the pump casing should not fall below the vapor pressure of the fluid for which we are going to use that pump. So at the end of this session you can explain the concept evaporation and boiling. You can explain vapor pressure, and also you can explain practical significance, means importance of vapor pressure. Subscribe the channel Thermal Engineering for further video sessions of fluid mechanics. Thank you.